Hi, Alexander. Thanks for coming today.
Hello, nice to be here.
Okay, great. So, when I am here, such a developer who has been contributing to so many repositories and have been involved in ecosystem for years, would you mind to introduce yourself and what are you up to?
Yeah, sure. My name is Oleksandr. I'm from Kyiv, Ukraine, and I'm currently here. I've been using Clojure for more than 10 years. I've stopped counting, but yeah, it's around that. Like you said, I've contributed to many projects, many open source Clojure projects. I've worked at Grammarly for 7 years. Used Clojure there. And for the last 3 years, I've been serving at Armed Forces of Ukraine, and now I'm able to um, use my skills at
Yes, yes, to
various
help your
civilian
country.
organizations. Yeah, and
Yeah, great job. Okay. By
it's an
the way,
important one. Yeah.
yes, yes, it is important. By the way, can I ask you how you got to closure?
Yeah. So it started at the university. I was doing university assignments. We had a lot of programming courses there, and I was sort of curious. Our main language there was Java, but I've been like trying out different things, seeing what feels more natural to me. I tried Ruby. I tried Scheme and Common Lisp at some point, kind of double there. But then um, so we had to build a lot of graphical user interfaces for the assignment because like there was some task to solve and you have to somehow present it. And doing that in Common Lisp or in Scheme was a little bit challenging.
Yeah.
So and like the easy way was to use Java, to use Swing, and so on. So at some point, I just went ahead and Googled for like is there a Lisp for Java for JVM, and there were a few options at the time, but Clojure seemed to be the most developed, the most mature one, so to say. So I picked it, and I've been using it ever since, so to say.
Yes, yes. One thing that is interesting for me is that when I look at your GitHub, you're not the classic developer who, for example, is focused just on web applications, but you contribute to different repositories, even different types. You are not focused only on web dev or only on Emacs, but you have been quite versatile. So, can you tell me what repositories you contribute to? What's your role there?
Yeah, sure. So I have this like several directions that I work on. One of them is editors and tooling. I'm a believer that like tooling is a great enabler for being productive, for feeling good about using something, using language in this case, because as we know. Um, Tooling overall, like IDE, things like Cider or like whatever else editor you're using and using Repelin, that is the great force multiplier, and it's a thing that makes you productive, that makes you want to use the language, which you otherwise might not want to use. Would go for something statically typed or with better error messages or like with all those other life improvements, but like all of this is outweighed by the power of the REPL and being able to package this REPL in a better,
Yes.
more convenient way. It's very important. So editors and tooling is one
Yeah.
direction I enjoy working on, and also like see the great benefit of doing that. The other one is software performance, uh, particularly performance in Clojure, but like overall, I'm a big performance nerd. Software for hardware, like uh, on different levels, I find something interesting, like how to improve the speed of something, or just understand like how it works and what makes it faster. And there are uh, there is no limit how low you can go, because like you dig down to the like CPU level details, and you research that topic and it's fascinating. But then you like dig even deeper, like some
Yeah.
voltage stuff, and how motherboards are built. It's like which how do they compare, which operational transformers are better for which kind of motherboards. So it's an interesting topic.
Yes.
You can find
Yes. And
find something interesting on every level.
it's very different. Like these two things are two completely different skill sets, right? Because when you are building a support for Clojure in Emacs, it's a lot of Emacs Lisp and learning how to interact with Clojure processes. While when you are speaking, or when you are learning and optimizing Clojure performance, it's more like JVM bytecode. Um, I know that you contribute to Metabase, right, which is web application development. So it's a third skill set.
Yeah. That's true. But at the same time, I'd say that for me at least, Clojure is language that um, enables me to quickly like jump up and down that stack
Yes.
without completely switching the context. You can do that within the same process, really. So it's like you're building something high level, but
Yeah.
then you notice, like if we talk about performance, you see that something is slower than it should be, slower than it feels like it should be. And
Yeah.
then like immediately right there you have tools at your disposal to instantly drill down, to dig deeper, to take apart like what's going on. You
Mhm.
have profilers, you have decompilers, all those sorts of things. You can see the Java bytecode for the particular function that you're measuring.
Yeah.
And so it's like it feels very natural and very easy to go on those detours, uh,
Yes.
which
Yeah.
of course it's a little bit of Yakushev, but
Yeah.
at the same time, it's like if you didn't have those tools, you would probably just put that away, like
Yeah.
delay investigating that. I'll check it some later time, and you'll just forget about it and never will come back. But like being able to do that, it's a great enabler.
If I can ask, also at Grammarly, weren't you working on natural language processing?
That's right.
Okay, so it's another skill set. So let me ask a question you might not expect. How do you learn?
Okay, yeah. All right. So I think I'm a little bit old fashioned in that I really like reading books on technical subjects, and it's like when I encounter some new field for me,
Mhm.
I try uh, to build this short list of preferably books, could be maybe some of the material, but overall it's like uh, I need some lay of the land introduction, but kind of like structured one. I don't feel like I learn well when there are just pieces of like split information here and there, and like some YouTube video, something like that. I don't learn very well from that. I just I like when it's structured by somebody else. Doesn't have to be ideal, doesn't have to be like 100% uh, relevant information to me, but uh, kind of something generic, general one, but then something more concrete, more specific, and I go
Yes.
from the more general to the more specific one,
Okay.
and on the way kind of
Yeah.
build
So
my
you start
understanding of the topic.
with learning the theory
Yeah,
before you. jump to the doing the thing. Okay, okay.
and that helps me understand, or at least I aim for that thing, to understand like why certain decisions were made, why things are like
Yes.
that, not the other way around.
Yeah, yeah. And for example, with Emacs, yeah, I have seen a manual. Like it was free. It was like 700 pages,
Okay.
and it wasn't even a developer guide. It was like a user manual. So there is a lot of theory. Um, what skill set one needs to let's say build extensions for editors?
Okay. For me, again, it happened naturally that I started like extending and building these tools, because um, I mean it only takes just starting using Emacs, because
Yeah,
in a configurable editor, very often people don't just um, don't just stay at the basic configuration. Like if you install bare bone Emacs, it's pretty unusable.
yeah,
But there are some good pre-configured packages right now, like Doom Emacs, Spacemacs, and
yeah,
it is possible to just install and forget that. But what happens more often is that people who install Emacs, who get into Emacs, they start tinkering with configuration, then they get into, okay, I can copy and paste some function from here and there, something to
yeah,
improve my. And I think it's just gradually you get used to, even just it's just the idea that editor is not something set in stone, but
yeah.
in fact, it's a REPL, it's a live system that
Yes,
you can modify on the fly, and you
yeah,
immediately see the result. And
yes,
the editor itself helps you develop itself again. It has a debugger, it has all these different tools that enables you to do that. And that's what happened to me. It
Mhm.
started like just
I think
tinkering.
I think even the paradigm of Emacs is really you are supposed to modify it
Yeah, pretty much.
more than any other editor. I would say Vim is usually modified by people, but not to that extent. People create their own mappings, but I don't see people that often having that. So to Emacs or Spacemacs, it's a huge pack. But even when we speak about homebrew customizations, people end up really building their own Emacs.
Yeah.
That I was working on Emacs with a friend of mine. We were pair programming, and I wasn't able to do anything. But partially because it was so heavily customized, but also he was using Dvorak keyboard, which didn't help. Uh, and in other editors, it's really not like this. The second thing is really there are people who are trying to live in Emacs. Like,
Yeah.
are you the type of guy who would ideally browse internet, answer emails in Emacs?
Yeah, probably not like that. I
Yeah,
don't try to do everything in Emacs. It's mostly, it comes down to what is really easy to do, like what where Emacs really shines, versus where it feels tacky and just like a hack. So I mean, browsing internet, yeah, I don't do that. I know people, for example, they use Emacs terminal, like they use terminal
yeah,
inside Emacs for everything. That never worked for me very well, because I like my terminal to be some other process where I have tabs with different shells, and I have a hotkey to quickly bring the terminal up and down on any, like on top of any screen, any window. So Emacs didn't fit that well for that. But on the other hand, of course, I use Magit, which is Git.
Extension. Yeah.
Yeah, Git shell inside Emacs, and I use it everywhere. And like even if I develop some project not in Emacs, in something else, in IntelliJ, for example, I still interact with Git, Magit.
Germany.
Yeah, I have Emacs on the other
Interesting.
screen. Yeah, because it's just, I mean, I'm very much used to it, and it's also very powerful, so it makes sense to
Yes.
use. Or I use a file manager inside Emacs. That's also very convenient to me. So there is tired thing, and there are different wrappers around it, but it's that one is convenient, and that one is when people look kind of weird at me. It's like, why don't you use Finder or something else?
Yeah. That's interesting. Next thing is, so I don't want to torture you too long with LLMs, AI. Everybody speaking so much about it nowadays. But at the same time, there is a topic like developers are adopting. There is Copilot, there are Claude, Cursor, and so on, and the workflow is changing. Now, Clojure developers do most often they do REPL-oriented development, and you work like in REPL-oriented workflow. You work in small iterations. You always test. You are trying that things work, and you inspect how they work, and you never write like 50 lines of code without testing it. It would be more like 1 to 5 lines of code.
Yeah.
5 only are easy or simple. And now, how is the workflow of developers going to change in upcoming years? Like what uh, editor developers or the editor extension developers, how they will have to adopt to what's coming most likely?
Okay. I'm probably not the most proficient person to speak about this. I haven't integrated any AI tools into my workflow so far. So I
Yeah.
use LLMs, but very in very old-fashioned way. Just it's funny to say old-fashioned when it existed on for a few years so far. But yeah, that's how it works these days. Things are changing very fast. But yeah, I just use it through a browser. I don't use any extensions, things that write code for you and you only apply div. Uh, haven't tried it yet. I think I will have to at some point. But overall, I think so. I have no idea how it will change in 5 years, in 10 years. It very much depends on what kind of code we will be writing, and will it be in the current languages we use? Maybe there will be some very LLM specific languages that we'll have to learn to be able to leverage the LLMs and the tech of the future in more effective way. Because I mean, all of the languages, all of the frameworks that we have so far, they are still human oriented, right? And they
Yeah.
were developed for the purpose of like humans to be able to write that, to use them efficiently and to read them
Yeah.
later and so on. But maybe it's not something that AI needs, or probably it's not something that AI needs.
Yes.
Maybe
Yes.
we will have to settle at some middle point between like where humans can
Yeah.
still comprehend what is generated, but it's something
I
that is easier for AI
yeah.
to be generated at scale.
I think the biggest change is that nowadays, editors, there are two incoming sources of the source code. Either you type the code or you pull and check out. You check out some commit, so Git changes the file in one step. While when you type, you are changing one character at a time. If you don't use like multiple cursors and so on, While here you are like getting diffs, and these are applied, and developers need a way how to quickly get through them, do a code review, give some feedback. So I guess the flow might be more focused on like dynamic pair programming, where somebody virtual is sitting next to you and is doing changes, but not in the form of typing, but in the form of patches.
Yeah,
So,
yeah.
yeah, yeah,
But there is another dynamic, I think, that will change, and we don't know yet, like what results will it bring. So the tooling that we have now, be it editors and let's lump frameworks in there as well. It's mostly let's say it's a labor of love, in the sense that people who develop that, they like doing it. So, for
yeah,
example, if we talk about Clojure and tooling for Clojure, it's built mostly by people who love Clojure and love working with it, and they know how to improve their own efficiency, their own productivity by using tools, by improving tools. So it's kind of like this dog fooding process. You know what you need, so you build it or you improve it, and you give it to other people because they can somehow use that too. But if we start going that route, that you need to be doing actual development, actual coding less and less. And at that point, we have fewer people who enjoy doing it, who still
yes,
know how to do it, and that diminishes the incentive to improve tooling, because like if nobody does the coding, then like what is the purpose? So maybe we would go more and more into like this area where the tools, IDEs, and editors, and so on, it's mostly like given top down from big corporations that kind of developed these big projects, and by just like using economy of scale, they distribute that to all the developers who really don't care anymore whether they're tools sharp, whether they like enjoy doing the development with the
yeah.
tools.
There
I mean,
are there are definitely multiple steps in how you can use those tools. Where on one side is you are still like, yeah, you let the AI to generate only a few lines and you still use REPL,
yeah,
and then you understand every single line, you test it as usual. Then there is the second approach where you let it generate whatever it wants to generate, and then you go, you review it, you test it. Sometimes it's 10 lines of code, sometimes it might be 300. Then there is vibe coding, where you basically, and often you can use some application that you allows you to dictate what you want to do. So you are speaking to your editor, it's editing the code. You don't review the code, you just refresh the app, see how it looks, how it behaves, and tell it, okay, move this to the right. Don't forget to validate email addresses. And it's changing. Then I have heard a term, chaos coding, where you just tell it, this is the type of app I want to do. And every time you get an iteration, you will say, just make it better, make the design better, add some screen, add some feature, you let it drive. It's crazy. It's chaos coding, but um, I believe there will be people earning money with chaos coded apps because I have
yeah,
seen some and they look good. They look kind of similar to what already exists, which is logical for LLMs. But yeah, but if we speak about well crafted applications where developers really know what's happening, vibe coding and chaos coding is not going to survive. And a good thing is that there is a big distaste to these practices in the Clojure community.
yeah.
Um, so let's speak for a second about your career at Grammarly. So I
Okay.
spent 7 years there. You were working in Lisp,
Yes,
and you have also introduced Clojure there, right?
right. So when I came to Grammarly in 2015, it was already I wouldn't say Lisp shop, but one of the teams, one of the big teams that was working on the natural language processing part specifically, and they were using Common Lisp, and they had this big, complicated, in a good sense, complicated system written in Common Lisp. They used SBCL as the runtime, the exact implementation of Common Lisp, and they already used Emacs. They had like full developers and also linguists. Uh, they were using Emacs and writing in Common Lisp, and they already had some Emacs extensions that they implemented in house to improve the development experience for
Okay.
Lisp.
So, so does it mean that at Grammarly there are more guys like you?
Yeah, yeah, that's true. And uh, yeah, so the Common Lisp was already there, and when I came there, I started using Common Lisp. I started implementing features in that Common Lisp system. But for a few greenfield projects, I kind of brought this idea of using Clojure because I was already proficient with Clojure back then, and there were certain limitations with using Common Lisp like everywhere for new project as well. So I kind of made my point that Clojure could be a better suit in
Yeah,
certain
yeah.
and and it's like gradually spread, and we did more and more uh, new systems in Clojure, and eventually we even rewrote and replaced the biggest Common Lisp with the Clojure implementation.
If you had to say what are the pros and cons of Steelbank Common Lisp?
Hmm Uh, the the Common Lisp system that Grammarly had, I'd say, well, it was really state of art, really nice implementation, like natural language processing engine and like uh, different features that are required to make it work. And them using Common Lisp, it was really novel, and it really fit. Like, I mean, the regular advantages of a Lisp, like it being a system with a REPL that you can interact with and you can quickly iterate. And so in that particular case, for example, it's a big system that takes a few minutes to spin up. And of course, you don't want to wait for that time. Like every time you modify a test or change some function and so on. So like those are the usual Lisp benefits, of course, apply to Lisp as well. Um, so another benefits, for example, I think they started not with Steelbank, not with SBCL, but with some other Lisp implementation. But then they were able to quite seamlessly switch to SBCL. So this thing with Common Lisp, with it being a like specified language, and then you have different implementations. It really worked for the most point. There were just like some minor things that had to be modified, but otherwise, uh, it really is like that you
Yeah,
can use Common Lisp implementation, and they would be mostly compatible one with. And there were, I'd say, minor things, but still nice. The error handling solution in Common Lisp, it's quite powerful, uh, much better than what Clojure has, for example, in the terms of language itself. I mean, it
yeah.
still. that Clojure did the right choice to just leverage.
Would you want to elaborate?
Sorry.
Do you want to elaborate? How is this so powerful?
Uh, so I mean, has this powerful error handling system where it's a bit hard to explain in a short amount of time, but basically it's like exceptions, like throwing an exception and catching it, but it can go in both directions. So after an exception is thrown, and when you catch it, you can actually instruct the runtime to go back into the place where the error happened and do something
Yeah.
else. It's called the conditions and restarts, and it allows like the stack to be traveled in both directions, and
Hmm.
it's really powerful. You can implement very very complicated and elaborate error handling systems and on top of this. So that was used in many places of that common Lisp system, and it was quite beneficial. Uh, then the performance of SBCL was quite
Performance.
good. In fact, SBCL is a natively compiled, so it's compiled, it compiles to native code.
Yeah.
The resulting performance was pretty nice.
Yeah.
Then you can extend the reader in Common Lisp, so you can do really crazy like new syntactic things. You can do that in Common Lisp. Let's say it's much more flexible than the conditional reader
Yeah.
things in Clojure, and that can be a benefit and a drawback as well. So
Yeah.
people do
Yeah.
really crazy things with
Yes.
reader macros in Common Lisp, but they were used Grammarly to overall to an advantage.
What about disadvantages of as a
Mhm.
steel back onlys?
So the disadvantages, which eventually were the main reasons why we wrote the Common Lisp system to Clojure. Um, I'd say the main one was the communities much smaller than the Clojure one. I
Yeah.
mean, Clojure doesn't boast a huge community, but still, it's larger than the one
Yeah.
for Common Lisp. And what that results in is like there are fewer libraries, and the ones that are there, they are very often like a lot of them are abandoned. Some
Mhm.
people say that it's okay for them to be abandoned because they still work,
Yeah.
but I mean it's not always like that. Some things break, some things get obsolete, some things need security patches, and so on and so forth. So it's actually important for like to have a set of libraries that are actually worked on at least
Yes.
some time, like being looked at. So that was one of the reasons, and the second drawback, let's say, is that Common Lisp has its own runtime, so it's not as easy to leverage existing things like this Clojure because Clojure runs on JVM, and you basically can pull any Java library and start using it like from the
Yeah.
get-go. And with Common Lisp, you can use native library, but it's not as convenient, and it
Yeah.
requires more effort to to do it if there are no existing wrappers, and the existing wrappers are not uh, like there are not so many, not
Yeah.
as as for Clojure. So that was the second reason, and then the third one, like I mentioned, Common Lisp had a pretty good performance, but in certain areas it was still worse than for Java. For example, garbage collector being one of them,
Yeah.
and especially in multi-threaded scenario. So when you try to scale the system vertically on bigger machines where you start like you have save 50 cores and you start
Yeah.
with 50 threads, and then like garbage collector becomes real bottleneck because it's really
Yes.
efficient as most of the JVM one, and that's why that's when you have to kind of get creative and run multiple
Uh,
instances of
yeah.
process. And it's overall, I'd say that's a point where it's it's not as good as it might be.
Yes. Yes.
So in the
The last thing I would like to ask you about Steelbank Common Lisp, if Clojure was not available to you and you had to choose an app to build some kind of application, would you still consider SBCL as one of the options?
I think so. I mean, either SBCL or maybe some other Common Lisp implementation, but I would certainly look in Common Lisp direction. So there are actually Common Lisps available that run on top of JVM. So ABCL is one of them, ARM Bear Common Lisp, but the last time I've heard of it, I think again the performance story in it is not as good as in
Yes.
SBCL and not as good in Clojure. It made certain decisions. It had to make certain decisions to be closely to look to represent and to resemble Common Lisp as much as possible. It is a Common Lisp after all. It has to follow the spec,
Yeah.
but that's where it had to make these trade-offs that impacted performance, and so that might be a problem. But I would still consider it. I would look into it.
Yeah. Have you ever tried any scheme dialect?
Mostly just for experiments for learning, nothing.
Mm-hmm.
But yeah,
Nothing.
I tried Racket. Just think of it.
Yeah, yeah. I wanted to ask about like if you like the ergonomics of Lisp more than ergonomics of Scheme. I like the elegance, but at the same time it's a language that's trying to be more minimalistic, and it might be a little bit more noisy in some
Yeah,
situations.
yeah, I agree. I agree that with Scheme, to me, it feels like the minimalism is better suited for for learning and for yeah, as an educational vehicle, not as much as a language to work professionally with. So
Yes,
in that regard,
yes,
Common Lisp feels more more industrial sort of
yes,
thing.
yes. But it's more about how the language is used. Like there is nothing stopping anyone from building a framework that would extend scheme to be more practical, right? There are ways how to extend syntax, etc. Now let's jump to your current work. I don't know how much you can say about what you do.
Right.
So, um, but you told me when we were speaking that you might have something interesting to say about the current work.
Right. So these days, like I said, I serve at armed forces, and specifically, I work uh, on a situational awareness, kind of like battlefield awareness system. We use Java to develop it, so no Clojure there. But overall, it's a system that is used daily, like on different parts of the battlefield. It's like used on the tactical level, on the operational level, on strategic level, uh, on the front lines, and like back at the headquarters. It has a lot of applications, a lot of uses, and mm, it's nice to to know that the work you're doing has an instant impact, and that's the feeling that I enjoyed working at, primarily because we were able to deliver things very quickly to our users, and it's this similar sort of feeling that I have right now, because again, it's the development cycle in our product is quite short, and it's it's very unlike most of the militech and overall
Yeah.
of the military hardware software, because those usually have like this very prolonged, very
Yeah.
extended timelines, and there could be like years could pass before the work that you've done
Yeah.
finally executed somewhere. And we don't have this luxury right now, because we are fighting a
Yeah.
war that is happening today, happening right now. And the faster we can make an impact and can improve the situation, can give better tooling to people, that like the more benefit it will have. Uh, yeah, time is
Yes.
of the most is the most valuable resource right now.
Yeah.
So yeah, I've told you before. It feels a bit. It's very similar to REPL experience to me in some
Okay.
sorts. It's just very. It highlights very well how this short feedback cycle, how important it is on different levels. Like you get to enjoy it when you use Clojure and you have a REPL with the fast feedback loop, and in the same way when you work on a product uh, that can deliver updates in a matter of hours, and people will use it immediately, and those people will then come back to you and say what's wrong, what works, what doesn't.
Yeah.
That is very valuable, and it allows you to be much more effective and productive than otherwise. So yeah, there is that. And a lot of our developers, they go to nature conferences, they get to like share experience. Our system is nature compliant in many ways, so like we have a shared vocabulary to that we can.
NATO standards. Yeah.
Yeah, exactly. And it's very telling how it's like how much faster we are moving right now than like many of the people from other countries, other nature
Yeah.
countries that we get to learn from and share experience with. I mean, it's like uh, in many topics we are right now a lot ahead than other countries, just because we get to see the immediate effect of the work, and we get to
Yes.
iterate
Yeah.
on ideas quickly, and we see the results
It's
in
the
real time.
it's the real agile development,
Yeah,
right? How it should be. And
exactly.
yeah, from my experience, it's I have been working with one company that develops for Czech army, and yeah, it was very like inefficient. You had two computers. One was online, and the other was connected to the army network. And you were developing on the army network computer. When you wanted anything from the normal internet, there was like those four eyes process where you cannot develop any data yourself. You need a second person, a military officer, to watch you, what you do, so they don't infect the network, etc. Here, as you say, you deliver changes in a matter of hours. If I understand, to many versions of Android. So yeah,
Yeah, it's not only Android. It's again, it's also funny how different our approach is from the regular established approaches in Miltech and like overall in the army. Because how it usually happens in the army, you have like this. You have this waterfall process, and it starts with requirements and specifications, and takes some time to work through it, and then you you settle on some hardware that probably will also have to be developed
yes, yes,
specifically for that project, and it takes a few more years, and then it's like you build those devices, and you then build software that only can work on those devices and nowhere else.
Yeah.
And we don't have this luxury of so much time. So if people in headquarters, or if soldiers on the front line, if they have, some of them have Android phones and some of them have iPhones, then we have to build applications for both, because
Yeah.
there is immediate value in doing that, as opposed to spending a lot of time and a lot of money to buy certain devices and distribute it to people, and then have a like uh, pipeline of replacing them because they will be lost. So yeah, it's completely different to how
Yeah.
things usually work in this area, and we see like immediate results and benefits of
Yeah.
doing it the way
Yeah.
we do it now.
Yes. Yes, very different from my experience. About 18 years, I built an ERP system for a Czech company that builds communication devices for army and police. And exactly, it was this year's model. This is how it was certified with the government. This is exactly what the police and army will get. And from now on, we can't do any changes in these devices until the next year version. Like the opposite of agile, complete opposite. And yeah, and back then I think, I don't want to speak badly about them, but I believe that these devices were already technologically behind, and this might be one of the reasons. So now you are working with Java. So you work with Java, Clojure, Common Lisp. So if we will speak about functional programming languages, they were quite popular. Let's say around 2015.
Yeah.
Then the mainstream moved on. It seems to me that some languages adopted plenty of constructs. Like if you work with modern Java, you might have records,
Yep.
lambda functions. So how do you see the impact of functional programming on those like mainstream languages? And did it also steal a chance for functional languages to becoming mainstream?
Yeah, it's a bit sad, actually, because you're right. There was this like renaissance of functional languages in 2010s, and then suddenly, or like over time, people stopped talking about them as much, and stopped being interested in them. Um, and it's not just Clojure, but I think Scala gradually fell out of fashion, and we
Yes.
don't talk about F sharp that much these days. So overall, yeah, I think functional languages are currently kind of in the slump, and one of the reasons indeed is that mainstream languages adopted a lot of the nice bits from functional languages. Java especially, like in 2010s, both Scala and Clojure and Plain were marketed as a better Java, and it was indeed one of the reasons to at least try those languages. But now Java picked up the pace, and the pace of developing new features is quite good in Java. Um, there is really not that many reasons to look into other JVM languages if you already know.
Yeah.
So that
Software
is
transactional memory. Software
sorry.
transactional memory. It's one thing that hasn't been adopted by the mainstream yet.
Yeah, well, it's not one that is very much used, and it's
Yeah.
not languages that has it. It was a neat concept, but it's still questionable if it delivers on the that much of a value compared to the drawbacks. But still, I mean, the other reason I'd say that overall the industry nowadays moved a lot, let's say, back into the area where it's very important to be backed by a big corporation, so that there is money in there. If we talk about programming languages, then it's like either TypeScript or Go or Java, because it has this
Yes.
corporate backing and many millions of dollars to pay people to work on it. And it happened with languages. It happens with databases, for example. So in the same years that functional languages were popular, say,
Yeah.
like all kinds of obscure databases were popular. It was very fashionable to try
Yes.
out new databases, open source. Yeah, so it was like very cool back then to do that. Nowadays, like, people are back to being very cautious. We don't want to run anything ourselves. We want to use something hosted. So whatever is offered as a
You're
service by
right.
Amazon, we'll use that. And
Yeah.
yes, it becomes
Yes.
a little
It's
boring.
CouchDB, and React. Actually, React is what got me into functional programming. It was in Erlang. I was a big fan of React back then, so I started learning Erlang because
Mm,
of that. Um, by the way, one thing that comes to my mind, Rust, a popularity of Rust. Um, it's a language that looks like as if you wanted to take as much as possible from Haskell and turned it into a language for the lowest level programming possible. So, so it is basically replacing something between C, C++. In some ways, like C is the level you target, C++ or more or higher is the level of expressivity you target. And Rust is super popular with high level programmers who were using Python before. Uh, do you have an explanation for that?
I can tell you my own perspective, how I got into Rust. I just a disclaimer, I haven't used it professionally, mostly like tinkering, solving lead code problems, that sort of use case. But still, so for me, Rust is a language that I can write really like low level down to the meta level code without having um, to learn C at the same like level of proficiency, not having to invest time and effort in learning the intricacies of C and all of the undefined behavior stuff that you have to avoid and remember not doing. So Rust is certainly easier in that regard. Of course, it requires you to learn a lot of new concepts that are very unfamiliar if you haven't used and learned Haskell that much, or like other this very statically typed functional languages. But still, so it's a bit similar actually to Clojure script in a way that I had no interest in web development until Clojure script appeared, and
Okay.
for me it was like, okay, so now I can still use Clojure, but kind of investigate like how this whole web development thing works, how it is done, like tinker with it, try some things. So it's kind of like just a gateway into something. And in a similar fashion, Rust was this gateway into low level programming for me. Uh, in that I felt like it would be interesting to learn it, and it would be fun, and at the same time, it's a way to uh, like to venture into some new field. So
Yes.
maybe for some people it's like that.
Is it difficult to work without a garbage collector in Rust?
Um, so the whole complexity of Rust is, in a lot of ways, it comes from this um, from this way to manage memory without the garbage collector, but at
Yeah,
the same time without like having to manually free stuff. So the main complication is from there. Rust
yeah,
is not as complicated like that, just because it was like people decided that they should do it this way. It's mostly a drawback, and it's a trade-off. Sorry.
yeah,
Um, is indeed not very easy to not as easy, let's say, as in Java or in Go. But if you accept the trade-off, if you understand like why it has to be like that, then you can power through it.
okay, okay. So now when we speak about low-level programming, it's like we can naturally speak about also your work about performance of applications,
Hmm.
which I know is a big interest of yours.
Right.
Uh, in Clojure, I wonder what makes Clojure run so fast.
So the main reason why Clojure can be fast, and it it is fast if written correctly, is that it runs on JVM, and JVM is very efficient and optimized system. Uh, you compile Java code or Clojure code to bytecode, but then that bytecode gets compiled to native code by just-in-time compiler, and from there it can be as fast and as efficient as like handwritten C code, assembly code, stuff like that. And so that is one thing that JVM brings. Another one is being very optimized and efficient. Garbage collectors, an overall memory management story, and JVM is quite stellar. And Clojure gets to use all of that for free or
Yeah.
for so to say. So that is one of the reasons. And another one, I'd say that again at the time when Rich designed Clojure, he made the correct set of trade-offs because like he had to put a Lisp on the JVM, and there is certain impedance mismatch between
Yes.
Lisp as an idea and JVM, which is this very imperative system. And so he could make different trade-offs. He might would have wanted to do the tail recursion optimization, for example, and that would require like building some different abstractions on top of JVM that would make it slower. Or he could have decided to implement the error handling system in a different way, more closer to Lisp with conditions,
Yes.
restarts, and so on, and not like just use the exception system that are native to JVM. But that would impact performance as well. So my point is that the way Clojure is designed and implemented, that it's in the end it's very close to how JVM operates.
Yeah.
The result in bytecode is doesn't introduce a lot of abstractions on top of what JVM already does. So there is no performance drop there.
Yes. Yes. Also, I would say one thing is if you look at so common Lisp can be built on top of 8 functions, right?
Yeah,
Um, it's a naive thing to do because it will be slow, but you can do that. And the dialect of Lisp by Paul Graham Arc, it's like 40 functions. And
yeah,
there was Shi and Shan. It was also like you implement 40 functions on any dialect of Lisp or maybe any language, and you get it. But you are on a too naive level. While Clojure adopts a lot from Java, right? You have like hundreds and hundreds of functions who directly take from Java, and that helps a lot. The Java compiler, does it generate a good bytecode?
Clojure compiler.
Yeah,
Overall, yes. So again, there is not a lot of overhead, not a lot of stuff that Clojure compiler injects additionally to what would be needed. Just like methods, calling methods, invoking methods, the passing arguments, all this stuff. Base Clojure constructs are quite lean in that regard. So there are not that many Clojure constructs and facilities that have a lot of overhead. Um, I have a few of the pet peeves of mine. For example, the for and do seek macros. Those are really, like, if you look at their bytecode, those are atrocities. They expand very very big chunks of bytecode with all of the problems that come from that. But like otherwise, Clojure is very lean in that regard, and Clojure compiler does a good job. It doesn't perform many optimizations, let's say. So Clojure compiler is very straightforward and very I don't want to say primitive, but it is slightly like that. So it's a single pass compiler. It never looks back at what it has already compiled. So it just like goes function over function and emits bytecode for that. So there could potentially be like optimizations hidden that you could have done if like the compiler was more elaborate, more intricate. But I mean, to me, it is fine as it is because
yeah.
uh, I work with it a lot and I already know about the gotchas and like the things you have to be aware of. So
Yes, yes.
it's not a
It's
big deal.
it's a good time to ask you about CLJ Java, the compiler. Uh,
Okay,
what is it and what does it do?
right. So Clojure compiler emits JVM bytecode. It doesn't translate Clojure code into Java and then
Yeah.
being compiled. It emits bytecode directly. And JVM bytecode is something that you can read. It's kind of similar to assembly in a way, and it it is beneficial to be able to look at it to understand like what exactly has the compiler produced. But it's not the most pleasant thing to look at, especially if
Yeah.
you have a big function. And again, it's a new obscure language that you kind of have to learn and know the semantics of it. You have to know that arguments are on the stack and they are like referenced from the stack. It's great. So the idea of CLJ Java decompiler is to take this bytecode output that Clojure compiler produces and decompile it as if it was written in Java. Uh, and what comes out of it is like this kind of weird, kind of messy, noisy Java code that never existed. Just to be
Yeah.
clear, but still looking at it and reading it is more convenient than trying to read the JVM bytecode. So
Yes.
that's the idea. It's a way to see what Clojure compiled into without having to learn JVM bytecode syntax and semantics and stuff like that.
Well,
It's a useful tool. I use it quite often just
yes.
to double check. So one of the things it shows, like if there is reflection anywhere in the function, it will tell you, like you will see it in the decompiled code. Of course, you can see that as well by using the dynamic variable to instruct the compiler to tell you about reflection warnings. But there are some cases where like even that will not show you that reflection is happening, but looking at the decompiled code can certainly will tell you that. Also, if you use primitive math, if you work with primitive numbers and mathematical functions, mathematical operations, the compiler will again show you in a nice way that this is indeed what is happening, what you wanted to happen, to the unboxed math functions to be used instead of the boxed ones, and so on and so forth.
Yes, yes, yes. So sometimes you might want to override things, do unchecked ads, and so
Yep.
on.
Yeah.
Yes, yes. And what are some things you have seen there? And I don't mean Clojure itself, but let's say application built in Clojure. What mistakes do people do, or what things people do so that their code is running slow?
Right. So there are there are the let's say the easy the easy things the easy to fix, the reflection being one. That's the obvious one. And like nowadays people, uh, I'd say the pursuit of avoiding reflection is much more common these days, and like, people like purposely uh, get rid of all of the reflection warnings from their code. So that's the easy one. Using immutable data structures everywhere, it's okay, except for like the hottest parts of your application. Like if you have
Yeah,
some very hot loop, it might make sense to replace that with something mutable, with the Java array list, mutable hash maps, things like that. So like,
yeah,
and that is because of the allocations. And I'd say like generically, allocating in a very hot path is a very common performance issue, the one that brings the slowdown. So that and again, math. If you do a lot of math, and with Clojure, it's very easy to overlook, to forget that there is some boxed math operation somewhere. And if it happens to be in the hot loop, in the hot part of your program, it uses and it's slower roll, so it will have this slowdown effect. Um, I'd say those are the main
yeah.
issues I observe.
Um, what about lazy sequences?
Right, sure, of course, that one as well. Uh, I'm I'd say I'm an anti-ambassador of lazy sequences in Clojure. Uh, this blog post called Clojure's Deadly Sin, and it's a play on the facts like sloth is one of the 7 deadly things, and like sloth, laziness, similar things. So in that blog post, I describe like all of the problems with laziness that I see with laziness in Clojure specifically, and there are quite a few problems with the like um, how it makes the program more error prone. Like it's a source of bugs, it's a source of misunderstanding, and also there are performance problems with like this data well, because like the way lazy sequences are implemented, you don't have this uh, linear collection in memory that is like tight, and things are next to each other. So it will be lazy sequence. It will be more spread out in memory, and iterating it will be slower, and mapping, like producing new values, new lazy values from existing lazy collection will also be slower compared to if you had a vector or array list and just went over it and produced another vector. So there are performance implications about using lazy sequences as well. And again, why the, why it's usually a problem is because in Clojure most operations are defined as operations on lazy sequences, or that they turn lazy sequences functions like map, filter, and so on. So it's very easy to produce lazy sequences in Clojure, even if you don't care, or like even if it wasn't your intention. So it is easy to do that accidentally, and it often ends up.
Do you remember how the bytecode around lazy sequences look like? Is it like adding a lot of overhead?
So the bytecode, the bytecode for lazy sequences, there is no such thing as like some specific lazy sequence bytecode. It's just calling functions, specific functions that do lazy sequence processing. But for example, things that I already mentioned, the for and do seek macros, uh, they are this huge because they have to deal with lazy sequences, and also there is this thing called chunking in Clojure, because like if Clojure implemented lazy sequences in this naive way where you always realize only one item at a time, and then like the rest becomes this again new sort of data structure. So like going over each element has allocation overhead and so on. So if Clojure did that, it would be even slower. So in order to avoid that, Clojure has this concept of chunking, where a lazy sequence is realized 32 items at a time,
Mhm.
and that at least amortizes some of the overhead of lazy sequences. But in order to accommodate that, Clojure in several places has these facilities to account for chunking, and for macro, for example, is
Yeah,
one case where that happens. That's why, like macro, just looking at the macro expansion of for macro,
yeah.
is very telling usually that.
Yes, yes. So basically, if Clojure was somehow monitoring how the app is run, there is a potential optimization there if it knows that it will always like. So there might be infinite, like iterating zero is an infinite sequence,
Yeah,
but if you have a lazy sequence that always ends, the compiler could potentially realize the whole sequence if it knows that it's not consuming too much memory, and
yeah, yeah.
get to,
Technically,
yeah,
yeah,
even replace the functions that are being called with
yeah,
functions that does not have any overhead.
yeah.
Um,
Well, good news is that now we have transducers and like reducible contexts, and that is another facility that can achieve the lazy like behavior, but without the overhead of the lazy sequences. So yeah, these days, Clojure programmers can use transducers and reducible contexts to achieve the similar sort of behavior that they would use lazy sequences for otherwise, uh, and but without the overhead uh,
yeah.
of of a lazy sequence, and that's what I find myself quite often doing, is replacing lazy evaluation with some sort of an induction, or overall a transducer, and that really like that fixes the performance issues of that part quite often.
Yes, yes. And besides that, it can significantly, yeah, remove like all the memory allocation, right? Because transducers merge multiple operations into one, so you don't have to do one transformation, allocate memory for that, do another one again and again, but you compose it and you do it in one step. Now, the most important function, see, the most important thing today, how can people support you?
All right, so like at the personal level, this year I received Clojurists Together funding for the year, and I am very thankful for that. So people who support Clojurists, who contribute to Clojurists Together. already support me in a way. Of course, contributions are welcome to any of the projects I maintain or involved in. The Cider project and all the repositories that belong to it is always looking for people who want to contribute, to get involved in developing and improving Cider. And I don't think we mentioned it, but for example, Calva, which is the Clojure IDE for VS Code, it
Yeah.
actually uses Cider and REPL, which is the backend part, the part that sits on the Clojure side. So Calva and Cider share that IDE backend, and in a way, by improving Cider and REPL, you improve Calva as well. And so, of course, yeah, contributions are welcome. And on the global level, let's say, supporting Ukraine is very important to me, of course, and I'm glad that we still receive a lot of support from European countries, and I hope continue to it continues to be so, and we are grateful for that, and yeah.
Yes, I agree. I hope the Ukraine will win the war. Things will start getting back to normal as much as possible. Thanks that you found time for me today. It was a pleasure to spend this 1 hour and a quarter. And hopefully, let's do another call in the future.
Yeah, sure. Yeah, thank you for having me, and it was a pleasure for me as well. Thank you, Yuri.